Hi everyone, welcome to my channel. In this video, we are going to solve 6 different types of questions on binomial expansions. So let's start. Number 1, expand 3 minus x to the power of 4 in ascending powers of x and simplify your answer. This is a simple type. You just need to follow the formula that we learned in my previous video. So this equals to, I will start with 4c0. The first term is 3. 3 to the power of n minus r, that is 4 minus 0, is just 4. Then the second term is negative x. Make sure that you take this sign, otherwise your answer will be wrong. So negative x to the power of r only, that is 0 in this case. So 0 plus, then I'm going to increase the r, 4c1, 3 to the power of 3, negative x to the power of 1, then plus 4c2, 3 to the power of 2, negative x to the power of 2 because r is 2, and this is 2 because 4 minus 2 is 2, plus 4c3, 3 to the power of 1, negative x to the power of 3, plus the last term is going to be 4c4. This is when you need to stop when n is equal to the r. Then times, the first term is 3 to the power of 4 minus 4 is just 0. And then the second term is negative x to the power of 4. So that's our expansion. This equals to 4c0 in the calculator is just 1. Then 1 times 3 to the power of 4 is 81. And then it's nothing because anything to the power of 0 is just 1. Then for this thing, 4c1 is 4. 4 times 3 to the power of 3 will give you 108, but you also have a negative sign. So this is going to be negative 108x plus 4c2. 4c2 times 3 squared, that is 9, will give you 54. But what about the sign? It's an even power. That means negative x times negative x, that will give you positive x squared, plus 54 x to the power of 2. Then 4c3 will give me 4. 4 times 3 is just 12. But what about the sign? The sign, this is negative, and the power is odd. That means negative x times negative x times negative x will give you negative x to the power of 3. Okay, so be careful with the signs. This will give me negative x to the power of 3, and the number was 12. I'm going to write negative 12x to the power of 3. And the last term, 4c4, is just 1. 3 to the power of 0 is also 1, so you can cancel these things out. The only term that's left is x to the power of 4. This is an even power. That means it's going to be positive. So this is my final expansion. This is how you can just expand it in ascending powers of x. So you start with the smallest power of x, that is x to the power of 0, and then you keep on increasing it. Okay, so that's our simplified form. Then let's move to number 2. This is the second type of question. So in this question, we have f of x, that's a function. It equals to x plus 3 to the power of 7. And we just need to find the term in x to the power of 5. That means you don't need to expand the whole thing. All you need to do is identify the term that's with x to the power of 5. So let's see, how can we do that? So in my last video, we learned about the general form, that is NCR, and then you take the first term to the power of n minus r and the second term to the power of r only. In this question, the n is 7, it's given, so you can write 7c of r, and then the first term is x to the power of 7 minus r times the second term is 3 to the power of r. Now you need to figure out this value of r that will make this thing equal to 5. You can calculate that easily. That is 7 minus r. You want this to be equal to 5. This will give you 7 minus 5 equals to r. That means you want your r to be 2. Now all you need to do is just substitute r back into this equation. That will give me this equals to 7c2 then x to the power of 7 minus 2, and then 3 to the power of 2 only. How to simplify this? 7, 2, you can find it in the calculator, or you can also solve it by using the formula that I showed you in the last video. We use n factorial over r factorial times n minus r factorial. 7 factorial means 7 times 6 times and then 5 factorial. I'm not writing this whole thing because I have a 5 factorial down there and I can just cancel it out, because 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, and then 5 factorial also means 5 times 4 times 3 times 2 times 1. So you can cancel this out. Now you just have 2 factorial left, which is just 2 times 1. Then you can simplify it further by 6 over 2. 3, that means 7 times 3 will give you 21. This equals to 21 times x to the power of 5 times 9. That will give you 21 times 9, which is 189. Is it 189? Yes, it is. Okay, so 189 x to the power of 5. So the term in x to the power of 5 is just this thing. So for this kind of question, you just need to identify the value of r that will make your power equal to 5, or whatever your question is. So you don't have to expand the whole thing. All you need to do is just use this formula, and if you are allowed to use calculator in that paper, then you can just type 7c2 in the calculator, get the value 21, and then find this. Okay, so let's move to number 3. Okay, consider the expansion of x squared plus 2 over x to the power of 10. The first question is easy. All you need to do is just write down the number of terms of this expansion. Now, if you look at the first question, right, what was the power? The power was 4. How many terms did you have for this? 1, 2, 3, 4, 5. You always have one more. So because we start with r equals to 0, the same rule goes for all the expansions. This means the number of terms of this expansion is going to be 11. You just need to add 1 to your n. Now let's see how to find the coefficient of x to the power of 8. This can be a little tricky because you have two x variable. You have x to the power of 2, and then you also have 2 over x. That's going to make it a bit complicated, but we can do it. Don't lose hope. So, okay, I'm going to write the general term NCR. The first term is actually, instead of n, I'm just going to write 10 because I know it already. 10CR, the first term is x to the power of 2 to the power of 10 minus r, times the second term, which is 2 over x in this case, to the power of r. I don't know what this is, but this should give me, this has to be equal to x to the power of 8 and then something. And we need to figure out what this term is. Let's see. I just need to take out my x only. You don't need to deal with the numbers because all you want to find is this value of r. I'm just going to take the x. I have x to the power of 2, then I have 10 minus r, and then from this I just have 1 over x to the power of r. I want this to be equal to x to the power of 8. Now let's simplify this. This is not that difficult because all you need to do is just multiply. 2 times 10 will give you 20 minus 2r times 1 over x to the power of r as well. If you move this up, this will be equal to x to the power of 20 minus 2r times x to the power of negative r. It's one of the rules of the exponents that we learned before. This equals to x to the power of 8. Now, according to the rules of exponents, if you have the same base, all you need to do is just add up the powers. This will give me x to the power of 20 minus 2r plus this negative r, so this will be minus r, equals to x to the power of 8. This will give me 20 minus 3r equals to 8. I will move the 3r to the other side. This side I will have 20 minus 8 equals to 3r. this will give me 12 equals to 3r. That means my r is 4. Now that I know my r is 4, it's kind of easy to solve it now. I'm just going to erase this and substitute r equals to 4 into this term. This will give me 10c4 x to the power of 2 and then 10 minus 4 times 2 over x to the power of 4. What is 10c4? You can find it in your calculator, or you can also solve it manually. This will give you 210. 210 times x to the power of 10 minus 4 is 6. 6 times 2 is 12. X to the power of 12 times 2 to the power of 4, which is 16, over x to the power of 4. Okay, now if you simplify this, you need to multiply 210 times 16. That will give you 3,360. And when you divide two terms with the same base, you just subtract the powers. That means it's going to be x to the power of 12 minus 4, and this gives us 8. That is what we wanted. We wanted to find the coefficient of x to the power of 8, which is just 3360. That's your answer. Okay, if you want, you can pause this video and think about it for some time and then move to the next question, which is number 4. Okay, let's see what we have in number 4. We have 11 over a equals to 11 factorial over a factorial times 9 factorial. We need to find the value of a. Okay, now as I showed you before, n over r, this equals to n factorial over r factorial and then n minus r factorial. If you compare it to this equation, you can see this equals to 11 factorial and then you have a factorial. That means your a is the r, and then 9 factorial. So n minus r equals to 9. Then you can solve for it. N minus r equals to 9, because you know n already, which is this 11. I'm just going to write 11 minus r equals to 9. Move the r to the other side, and this side I will just have 11 minus 9. That will give me 3. Sorry, what am I saying? 11, forget that this ever happened, okay? 11 minus 9 is 2, so this is my r. Now that I know my, by the way, this is not r. After that, you can write this equals to a, because in this question, it's r is referred to as a, okay? Now that I know my r is 2 or a is 2, I need to expand this. Actually, I don't need to expand this. I just need to find the coefficient of the term in x to the power of 9. Again, the general term, that is 11cr times the first term, 11 minus r times 3 to the power of r. You want your x, the power of x, to be 9. That means you want your this thing to be 9. Actually, that's what you solved in this question before. So 11 minus r equals to 9. That means 11 minus 9 equals to r. This will give you 2. Your r is 2. You just need to substitute it back into this equation. So how to do it? I'm going to erase this part and I'm just going to substitute 11c to 11 to the power of 11 minus 9 and then 3 to the power of 2. 11c2 will give me 55 times, okay, why did I write 11? That's x, by the way. Okay, 55 times x to the power of, this is also 2, oh my god, 11 minus r, r is 2, so you need to substitute 11 minus 2. That will give you x to the power of 9 times 3 squared, that is 9, equals to 55 times 9. This will give you 495 x to the power of 9. So this is your coefficient of x to the power of 9. Your answer is going to be just this. Okay, let's move to number 5. Let's see what we have. Oh no. Now we have 3x plus a times 2x plus b to the power of 6. And we need to find the term in x to the power of 5. Let's see how to do that. This is my question, 3x plus a. This is a bit complicated because this is just not going to be one term, because you also have this. So you will have two terms with x to the power of 5 and maybe more, and then you need to add all of those terms. So let's see, how can we get, what are the possibilities of getting x to the power of 5? One possible thing is, if you multiply this x, 3x, like whatever you get here after you expand, you need to multiply it with this. So whatever your x is here, it's going to change if you multiply with this x, because you have one x. And the only way that you can get x to the power of 5 is if you multiply something here with x to the power of 4. X to the power of 4 times x will give you x to the power of 5. So that's one possibility. You want to find x to the power of 4 in 2x plus b, this thing first. So let's do this thing first. According to our formula, I am going to have 6cr 2x to the power of 6 minus r times b to the power of r. You want this term to be 4. That means 6 minus 4 equals to, 6 minus r has to give you 4. If you do that, if you move the 4 to this side, your r is going to be 2. That means the power of this, the value of r has to be 2. You don't even need to do this. If you just look at it and see 2 is the only thing that you can subtract from 6 to get a 4, you can do that right away. I'm just showing you like step by step. This will give me 6c2 2x to the power of 6 minus 2 is 4 times b to the power of 2. This equals to 6c2 will give you 15. 2 to the power of 4 is 16. X to the power of 4, and then you also have b squared. This will give me 15 times 16 is 240 times x to the power of 4, and then b squared. This is my one possibility. And then the other part that you can have is if you multiply something with a, sorry, I'm just going to move this down a little bit because I need more space. Okay, let's go back. Okay, now with a, you need to multiply this with something over here that has the power of x to the power of 5. Because you don't have any x here, so all you need is one term with x to the power of 5 from this this binomial. The idea is the same, but you just want different power of x, which is x to the power of 5 in 2x plus b to the power of 6. This will give you 6c. I'm not going to write it now. Let's look at this first. 2x, you want the power of this to be 5. And the only thing that you can take out from 6 is 1 to get a 5. I'm just not going to equate this again. I'm just going to write 5 straight away, and this will give me 1, because 6c1, 6 minus 1 is 5. That means my r is 1 in this case. You can also write this straight away, times b to the power of the last thing, which is 1. This will give you 6c1 is c times 2 to the power of 5 is 32, x to the power of 5 times b. This will give you 192, x to the power of 5 b. You can also write 192 b 2x to the power of 5, and yeah, it's just b. Okay, so that's it. These are the two possibilities. Now we need to multiply. Okay, so let's see. So for 3x, you want to multiply this term like something with x to the power of 4. In parentheses, I'm going to write 240 x to the power of 4 b2, and then plus a. You have to multiply a with 192 x to the power of 5, and then b. Okay, this will give me x, 3 times 240 will give you 720, x to the power of 5, b to the power of 2, plus this is just one number, 192 x to the power of 5, and then a times b. Because you just want the coefficient of x to the power of 5, you are going to take that out, and inside this parenthesis, you are going to write what's left. So we have, from the first term, we have 720 b squared plus 192 ab, because you already have the x to the power of 5 outside. So this is going to be your answer for this. Okay, we are almost done. We just have one last question left, number 6. In this question, this is also a tricky question. That's why I wanted to show this to you. In this expansion, you have to find x to the power of -2. Now, it's not possible to do it like number 5, because you can have lots of possibilities here. Like you have x over there, x here, x there. So it's kind of confusing. That's why for this question, I'm just going to expand it. And then I'm going to see what products you need, what terms you need to multiply to get x to the power of -2, which is also the same thing as 1 over x to the power of 2. Then let's expand the first term, which is x minus 1 to the power of 3. This will give you 3c0 x to the power of 3 minus 1 to the power of 0 plus 3c1 x to the power of 2 negative 1 to the power of 1. If you know the formula, you can also use that straight away, no problem. I'm just showing it to you, like how to do it by using binomial expansion. X to the power of 3 minus 2 is 1, and then minus 1 whole squared plus 3c3, the last term for this, x to the power of 0, and then -1 to the power of 3. Okay, 3c0 is just 1, and then x to the power of 3. This will get cancelled out because anything to the power of 0 is 1. Then you have a negative sign. The power is odd. That means you're going to have a negative sign. 3c1 is 3x squared. Then this is even. That means this is going to be positive. 3c2 is also 3 plus 3x. The last one, this one is 1, 1, and then an odd number, odd power. That means it's going to be -1 only. This is my first term, and for the second term, it's 1 over 6 plus 2x to the power of 6. Okay, this is going to be long. Brace yourself. This equals to 6c0, 1 over x to the power of 6, 2x to the power of 0, plus 6c1, 1 over 6 to the power of 5, then 2x to the power of 1, plus 6c2, 1 over x, 6 minus 2 is 4, and then the second term is 2x to the power of r, which is 2 in this case, then plus 6c3, 1 over x to the power of 3, 2x to the power of 3, plus 6c4, 1 over x squared, because 6 minus 4 is 2 again. And the second term is 2x to the power of r, which is 4, plus 6c5, 1 over x to the power of 1, 2x to the power of 5. Oh, thank God, this is our last term. 6c6, 1 over x to the power of 0, and then 2x to the power of 6. Okay, now let's simplify. I know 6c0 is just 1. That's easy. The first term is just going to be 1 over x to the power of 6 plus 6c1 is 6. 6 times 2 is 12. This will give me 12 over. Now for the x, look at this. You have 1x over there, and here you have x to the power of 5, so which is x to the 1 over x to the power of 5 times x. This will give you x1 minus 5, that is x to the power of -4. Or it's also the same thing as 1 over x to the power of +4. I'm out of battery, just give me a moment. Okay, so then I can write 12 over x to the power of 4. Okay, then for this term, 6c2 is 15. 15 times 4. 15 times 4 will give you 60. And then for the x, you have 2 up there, 4 down there. 2 minus 4 is -2. That means you are going to have 2 here. Plus 6c3 will give you 20. 20 times 8 will give you 160. This will just be 160. You will not have x because x to the power of 3, x to the power of 3, they cancel out each other. Plus 6c4. 6c4 will give me 15. 15 times 2 to the power of 4 will give me 240. 240, and then x times, x to the power of 4 over x to the power of 2, that means that's going to be x to the power of 2, plus then the term after this will give us 192 x to the power of 4 plus 64 x to the power of 6. Now that I have all the terms, just look at this. Now that I have all the terms, I'm going to arrange it accordingly. So 64 to the power of 6 plus 192 x to the power of 4 plus 240 x squared plus 160 plus 60 over x squared plus 12 over x to the power of 4, and the last term is 1 over x to the power of 6. I'm just arranged it in descending orders. Now let's look at this. This was our first expansion. I am going to copy this so that it's easy to compare. Okay, I'm just going to copy this and move it down here. Then I'm going to see what can you multiply to get x to the power of -2. Okay, let's see what are the possibilities. There is nothing that you can multiply here with this to get x to the power of -2. Even with 192, there is nothing that you can multiply over there to make it equal to x to the power of 2. Same thing goes for 240, not possible, and 160, not possible. But 60 over x squared, you have 1x squared already. I'm going to take this term, and if you multiply this 60 over x squared times -1, you will get a term with x to the power of 2, like 1 over x to the power of 2, which is the same thing as x to the power of -2. Then what else I have? Okay, let me check this. 12 over x to the power of 4. If you multiply this with something, with x squared, you will also get x to the 2 down there. And this is our term. I'm going to write 12 over x to the power of 4 times -3 x squared. Okay, I think that's all. This will give me -60 over x to the power of 2, -36 over x to the power of 2 as well. This equals to -96 over x to the power of 2, and the coefficient of 1 over x to the power of 2 is just -96. So that's your answer. Okay, so if you think my video is helpful, then don't forget to subscribe. Thank you for watching. See you next time. Bye bye.